Sir, wait. There is some connection issue with expert. Again, he have left. Hello.
सर सर्च मध्ये डॉक्टरांनी डॉट मध्ये स्पेस टाका ना, ते त्यानंतर सर्च होईल ते.
नाही सरची गरजच नाहीये. मीच स्क्रीन शेअर केलंय.
Okay. Okay, things are this thing now. I can share my screen.
Share.
Very
Okay.
thankful to the coordinator for helping me during this particular time. I'll just start sharing.
Just wait. I will make you.
Am I audible, sir?
Yes.
Okay.
Now you can share your screen.
Okay. Thanks a lot, sir. Thanks a lot. Okay. I'll be just hold on. Let me open the demo first, and then I'll go back to this thing, which is important but not as important as the demo. Just hold on. Okay, this is there. Then just hold on, sir.
Yes, sir. Please share your screen.
I'm audible, na, sir?
Yeah, you are audible. Share your screen.
Oh yes. Okay. Okay. Sir, can you able to see the screen?
Yes.
Okay. So, this is our this thing. Just hold on. This is our home page of the lab, and we have developed multiple different tools for multiple different agencies. So what I'll do is I'll remove it from here. Okay. So this is our explore research tab, and if we go to a bit down, we will see this particular thing. Just hold on. System. Okay. Just hold on. We'll give the demo first. Go to the resources, and yeah. So, sir, please give me a quick feedback whether my screen is visible to you.
Yes, sir. Yes. Please continue, sir.
So, this particular teaching learning tool that we have developed along with our students' work. So, it's a data-driven healthcare research study, clinical trial analytics. As I have already said, why clinical trials are important? Because it gives you an idea of the product market fit, not the basic research. So, multiple basic research are going on in automation on mechanical systems. So, I am not going to that detail. So, my domain is healthcare research, and therefore we are interested in this. So, let's go to the resource. When we click on the access resource button, an email will be sent to the person for whom we have developed this tool. Okay. So then if we click the OK button, this thing will start. The database, not exactly database, let's call it a digital tool. So here, as you can see, this is our name, this is our lab's branding, everything is there, including our name and everything, as you can see here. So here we have analyzed 48 trials, clinical trials, which has taken place during this 24-25 time. Okay, this particular year, 48 trials. In every trial there were at least 125 average number of patients are 125. So total patients in these 48 trials were 6020. That means these studies are given on real people, not in pen and paper, not in vitro kind of study, not in the lab, but in the field. So there are 34 positive results and 16 different types of mechanical automation has been used in this, in 9 different categories. Okay, so we have developed this tool for a similar as I have said edutech startup who are in this thing automated robotics teachings to school students. Are you getting my point? So we are collaborating with that particular company. They have given us the fund to deliver this. We have developed this particular tool for them, and here you can see that what are the different trials by category. So as I have already spoken, for rehabilitation 44% trials are on rehabilitation. These are global studies, global 48 studies which are on this thing. 44% studies are focusing on rehabilitation. Now what does it show you? It shows you where your opportunity lies. For example, you are teaching a student who is in, let's say, in final year of this thing, mechanical engineering. You are teaching him the special paper which is robotics. Okay, it must be there. So in which domain he should focus on? It's the real-time data which is custom made and which is reliable, 100% reliable, because all are from peer-reviewed studies, not only theory research but from clinical trials. So rehabilitation just for 44% studies, then dentistry, oncology, cancer, which is again a big category, then critical care, sleep medicine. You will be amazed to know that sleep medicine is also a very lucrative this thing. I do not know whether you are aware or not. There is a thing called sleep apnea. If you snore a lot during your sleep, there must be something wrong with your system, and it eventually leads to some kind of fatality. I hope I am audible, sir. Coordinator, sir, I am audible, na?
Yes, sir. Yes, yes.
Then there is a thing called orthopedics, okay, bone related deformities, these things, and then there is surgery, then there is mental health, this thing, pulmonary medicine, and many more. Okay, so here medical robotics are doing excellent. Okay, and there are many number of clinical trials going on. The outcome. So there are positive outcome approximately for in 25 this thing. So what are the different types of outcome which those clinical trials have mentioned? Okay, so most of this thing has given a positive response. That means the techniques or the clinical trials has given positive results. Some are non-inferior, then comparable, then superior, cost effective, feasible. So these are this thing to make a student understand that whether it's a good opportunity to further study. Okay, then patient enrollment. So highest number of patients were enrolled in oncology for cancer. Okay, then dentistry, rehabilitation. Number of studies are more, but patients are more in oncology. That means in this thing. What does it mean? It means that the bigger market is where in cancer research. Then orthopedics, surgery, and many more are there. Sleep medicine is also there, as you can see. Then there is different types of robots. So what are the different types of robots? That robots means mechanical systems that has been used. First and foremost is surgical robot, where most of this thing has been in surgical robot. As I have already mentioned you, they will write a small code themselves because they are integrated with unsupervised or supervised algorithm based on different companies. The surgical system that I have already given an example, Da Vinci, is designed by Siemens. Now Siemens uses a unsupervised algorithm for this particular thing. So going on, then there will be exoskeleton, rehabilitation robots, then BCI robots, bariatric robots, which will help you to reduce weight. Okay, so give you a more superior. For example, somebody has gone through this thing, what do you call is some surgery on the back. In that case, they cannot hold a lot of weight, even their body weight. In those cases, this robot. Then transoral robotic surgery through mouth, if some surgery has been taken place, these are also in trials. Then bronchoscopic robots, that means which help patients during many bronchoscopy related thing. For example, if there is a critical patient whose lungs has been collapsed, so he should be given a critical care which is known as ventilation. Now in ventilation also is you must have seen that there is an artificial lungs. So for that constant pumping of air is taken place in a controlled fashion. So those things are already there. So and there is trials over time. Okay, so then we can also have the, as I have said you, that these are interactive type of this thing analysis. For example, let's go to this particular analytics tab. If we go to the analytics tab, what we'll see? We see that patient distribution by outcome, positive number of outcome is this thing 25%, and then superior is 9%. Likewise, only one result has been negative. Negative means there are in clinical trial, negative means giving bad results. That means it is not helping the patient but increasing the symptoms. So here this is category performance matrix. Okay, so it indicates that in which case highest number of this thing in dentistry, rehabilitation, sleep medicine, the results are very good. But in oncology it is mediocre. In orthopedics it is superior. But best results, that means best results has been found in dentistry, rehabilitation, sleep medicine, and likewise. Disease area analysis. So rectal cancer, 1072 patients has been enrolled. Similarly, what are the different diseases for which? For example, stroke. In stroke there are 10 studies and 594 patients has been enrolled. Then success rate by significance level. This is also very important, that success in which type of success. Making no difference is also a success, because at least it is not giving any bad result. So this kind of this thing is there. Then trial details. So these are all interactive. Okay, it is not a spreadsheet kind of thing. So here what you are getting, that what are the different types of clinical trials. So 48 trials were there in robotic versus laparoscopic rectal cancer surgery. So there was a analytical study where surgical robots were used. At the same time, normal laparoscopic rectal surgery was also used. So what was this thing? The significance was very high, because it's a very important area of this thing, medical intervention. Then the results were non-inferior. Non-inferior means at least comparable. Okay. Then there is radiotherapy versus TORS for oropharyngeal cancer. TORS means as I have said, an automated robot will identify the area where cancer is there and then project the radiotherapy. Okay, that means the radiation for cancer student. So here also the results were comparable. See, high significance. These are highly significant studies. Then micro ultrasound versus MRI guided biopsy. So biopsy is a method where, as I have said, that cancers are of broadly two types. In order to analyze whether it is a malignant cancer or a localized cancer, they should do a kind of biopsy. So for that, it's a small intervention. Some needle will be inserted into the area, suspected area, then some sample will be brought in, then it will be analyzed under microscope by particular staining, and basically cells are being observed under microscope, which needs a lot of intelligence. That means there should be at least an MD pathologist doctor who will do this examination, not any person like that. So his cost is very high. You must have friends who are doctors. You can talk to them, that to observe a slide in biopsy, it's a highly costly this thing. So what will happen if we can automate the whole process? So here, as you can see, this robotic versus conventional laparoscopic endometrial cancer. This endometrium is a female this thing genital system where cancers are there. It is also non-inferior. So likewise, all the analysis has been this thing in front of your students. So in detail they can study that which kind of automation is there, and whether the automation was impactful, whether some more research, more study in that particular domain will be helpful tomorrow to devise a this thing to build a solution around it. So this is why whenever we get some time, we use these studies to understand what is this thing going on in clinical research, because clinical trials are the thing which is not just in theory but also in practice. So patients will enroll, things will be applied on them, and eventually it will give you a good understanding that what exactly is going on. Then each and every reference is also been this thing, how many references we have studied, then each and everything, what are the journals we have studied. So these are all interactive. It is not that it's a static thing. So it is a kind of interactive design where you can teach your students about basic robotics and what is the exactly development of robotics taking place in medical purpose. So we have collaborated with this small company from Eastern India. They are teaching this robotics to school students. So we have built this particular tool to them. So in their case, we cannot directly share this link to you to understand, but this is our lab's branding. When they will use it for their this thing, so their branding will appear here. So this is the first tool that I wanted to demonstrate. Now coming back to the PPT, I'll just share the PPT now. And I'll also open this thing. Just hold on. I'll also open ChatGPT so that we can do the exercise, whatever exercise we have spoken about. Just hold on. 1 second, I'll stop sharing. Okay, just hold on. Let me open my PPT. Just hold on. Okay. Okay. So I'll share my screen all over again. Sir, give me a quick feedback whether my screen is visible, sir, and I am audible enough.
Yes.
Okay.
Yes.
So participants might have also done it. So I am again putting this thing command to ChatGPT and trying to see what exactly they'll do. Okay. So they will generate a number of iteration, means the lag period, the time it will do the small calculation, the robotic arm, and there is a this thing called tremor. So what happens, no, these robotic arms have some tremor. Some old persons are there, no, they'll have some shaky movement, na. So that shaky movement is also there in robotic arms. So if we do number of iteration increases, this particular thing also, where is the Excel sheet? Acha. Okay. Fine. Okay. So it's a very simple this thing only. So there is number of iterations, it usually increases the precision of robotic arm deployment. Okay. So what I'll do is I'll select these both columns. Okay. We'll try to figure out how what is the exercise, how a prediction algorithm takes place. So go to insert and go to this scatter plot, XY scatter plot. Okay. So now as you can see here, we have got an XY scatter line. Okay. And now what we'll do is we'll select this trend line and add a trend line on this. Okay. And we'll also display the equation on the chart. So this is the straight line equation, y is equal to mx plus c. Okay. Now here you see one thing. Y means what? Y means precision in the percentage of precision in robotic arm deployment. Hello. Madam, just madam. Yes, yes, first 5 minutes. So here what happens now, we have got a straight line equation where y is equal to mx plus c. Here no, y means precision in robotic arm, x is number of iteration. Now here you see, let's say a machine identifies number of iteration needed is 22.5. Now can we able to figure out what will be the precision in robotic arm deployment? Let us see directly, very easily you will see. So let us see what is the equation? 1.472 into x. So x is what, as I have said, 22.5. okay, then make it in a bracket. What we are trying to figure out? We are trying to figure out if the robot has identified that number of iteration needed is 22.5. Now we will try to understand what will be the precision in robotic arm deployment. Okay, so we are trying to figure it out. So here you see, so here now what happens, if the this thing is 22.5, number of iteration needed calculated by the robotic arm, because robotic arm is also this thing smart, and then what we'll find out is 85.5% precision in robotic arm deployment will be there. How we have identified? We have at first generated a training set. This is the training set, and then on the basis of that we generated this trend line, and the trend line equation was there, and from that trend line equation we identified this thing, isn't it? So this is how small predictive analytics is usually done. Okay, so there is time shortage, so we'll go to our next what do you call is next resource. Just hold on. Yeah, so first one was this thing, and then we'll go to one more simulation tool is there, biomedical robotics simulator. So again we have built this tool for our client. Just hold, as you can see here, this is our branding, SDN Analytics Lab, based on my name, and see these are the cancerous this thing. Okay, so we'll try the simulation start now, powered by as you can see here, SDN Analytics Lab, Women's Polytechnic, AICT, Tripura University, Government of Tripura. So we'll start the simulation now. Just hold on, I'll show you how it works. So there are two joints, the elbow joint is there, we have taken it here, and then we'll put it here, and then what we'll do is we'll grip it. Now it is open, now I'll close it. Okay, so we have identified it, and we'll remove one by one. So hand tremor is very less. Then we'll again remove it like this, and then we'll again open the gripper. It will deploy, and every time we will bring it here, small amount of cancer we will remove it. Okay, so it's just this thing to show you that how these tools will be helpful for our small students. Okay, so this is a medical robotics simulation powered by SDN Lab. Our labs this thing branding is there. When we have deployed it to the third party, their branding is there, and some instructions are also there. You can reset it, and then again you can start it. Okay, this is completely made by our lab, these two tools, this one and the other one we have already demonstrated. By saying so, I would like to conclude this session. There were several more things that we could have discussed. Please let me know if you have any questions, participants. We would like to interact.
Yes, participant. If you have any question, I sincerely hope that it is given you an idea that how exactly this teaching learning process will be. This thing will be in the next generation. In a couple of days, how we can enhance our ability to teach our students in a better way. By saying so, I would like to conclude. If there is no question, I'll take your permission to leave. Sir.
Please.
There is one question in chat box. What is precision of models developed for the prediction? POV medical images.
No, the platform is not open source. As I have said that we are doing it in a basis, collaboration basis. If you are interested, you can definitely. My was given in the screen first. My contact details are there. We can definitely collaborate. We are open to collaboration.
Kindly share the link of the download data shown us. Okay, what is the precision models developed by predictions, POV medical images and object detection? That particular thing we are also interested in, medical image processing and all. We'll definitely have an interaction with you. Please.
એ તો તમારે એમેઝોન પર હોતવાનું ને આ વસ્તુ મળે તો તઈ બતાવે એવું હોય.
Sir,
हाँ,
good evening, sir.
good evening. Good evening.
Sir, this is Anil Kumar, Skill
please.
Development Director of HINGNE University, Andhra
Oh,
Pradesh.
absolutely great. Yeah, tell me, sir.
So, sir, actually, you have shown that it is developed by you, so we are interested in collaborating
Sure.
because we have specialized programs related to biomedical and robotics and automation,
Great, sir.
where we
Great
have this
news.
course running from last 4 years onwards.
Oh,
Biomedical for a very long back, and for
Okay.
biomedical students, we are teaching honor course in medical robotics.
Oh, great.
So we
So
had
it will be
some
great
of
time
the
to
collaboration
interact
with our in and around hospitals also.
Oh,
Hello.
great.
So is there any possibility of knowledge skill transfer, sir? We're taking the help of
Sure. It will be
Tripura.
great opportunity for me also. Vignan University is a very prominent university like.
Yes, sir. We are a NRF 70
that
overall
is
university
very
category.
this thing. We will be very much this thing to interact with you, sir, in detail. So you can
Yes,
please
sir.
take my details. 84140.
Definitely, sir. I will.
WhatsApp.
I will also put a.
Sure. Thanks,
Please
sir.
once again share your details on the screen, sir. I will
It's
just
there
take
with
a snap.
our this thing, sir, coordinator, sir. Please.
Sir, I will share.
I'm just writing it down here. 841.
I will share my sir. Hello.
472
Hello?
is the WhatsApp. Yes, sir. Please, sir.
Definitely, sir. I will take your details from the coordinator, sir,
Yes.
Yeah.
and I will contact you, sir, because we also want to explore furthermore in the medical robotics also.
Sure.
Because in the field of mobile robotics and industrial manipulators, we had already MOU with Fanuc and all those companies.
Great, sir. Great.
So with even
we'll try to inculcate whatever things we have learned. We'll definitely
yes, sir.
at least 2-3 tools we will be definitely developing for you. That is for sure, sir.
Yes, sir. Definitely, sir. I will contact you.
Yes. So anything else, sir? Any other discussion to be this thing?
Any more question? Participant?
There were some couple of slides they are left, but it's since it's already time.
Okay. So if I think most of questions are answered by sir. So we sincerely thank Dr. Surjit Devnath, today's expert of AICT ATAL FDP, for enlightening session on engineering in medical applications and AIML assisted digital tools for real-time monitoring and biomedical robotics. So the session was highly informative and inspiring. In spite of many interruptions, sir, you have continued the sessions. So thank you, sir, for your sharing valuable experience. Thank you, sir. Thank you. Yes, participant. Now we have a second session. I think sir is already joined. Just I will see. Arshad sir.
Yes, sir. I'm already here.
Okay. Can you share your screen?
Yeah, sure.
Good evening to all. Again, it is my great pleasure to introduce today's second expert, Dr. Harshad Kumar Tange. We will be delivering expert session as part of this AICT ATAL faculty FW program on AIML in next gen automotive system. Dr. Harshad is computer vision and deep learning engineers with huge professional experience specializing in applying AI and ML techniques to real world industry problems. Dr. Harshad is currently served as assistant manager at software at Lohia Mechatronic Private Limited Pune, where he leads advanced machine vision based defect detection system for manufacturing application. He holds PhD in electrical engineering from Taiwan University, Taiwan, along with master degree in computer engineering from Pune University, and his academic and research background reflects a strong foundation in digital image processing, computer vision, deep learning, and machine vision system. Professionally, Dr. Harshad has worked across reputed organizations including Lohia Mechatronic, Weberg Software Solution, Mechatronic Engineering, Mercedes-Benz R&D, Smart Integrated Manufacturing Research Center, Taiwan. His work spans automated defect detection, object detection and tracking, HT map feature generation, anomaly detection, and predictive modeling for industrial and automotive applications. Dr. Harshad has extensive hands-on expertise in Python, TensorFlow, Keras, PyTorch, OpenCV, and many more. He has successfully integrated AI-driven vision system with real-time manufacturing hardware such as camera, PLC, encoder, and automation system. Dr. Harshad is also highly accomplished researcher with multiple SCI and Scopus Index journal publication, international conference paper, and several best research papers award at national and international levels. His research contribution covers solar panel defect detection, lithium-ion battery inspection, biomedical imaging, and intelligent optical inspection system. With its strong blend of industry implementation, research excellence, and practical AI deployment, today's session promises valuable insight into how AI ML are transforming modern industry systems. So we are indeed privileged to have such a distinguished expert and researcher with us for this today's session. So I now request Dr. Harshad to kindly take over the session. Thank you.
Yeah, Dr. Parmeshwar, thank you so much for the introduction. It was a great introduction. I have never thought of it as well. Okay, good evening, participants, teachers, and faculties. I would like to really thank Zeal Institute for giving me the opportunity to bring up the research work and today's era, what AIML into automotive system. So before I proceed, may I please know from the participants if I am audible and the voice is clear enough?
Yes, sir. Yes.
Okay, thank you so much for the confirmation. Yeah, so as sir mentioned, I am Dr. Harshad. Currently, I'm working with Loya Mechatronics as assistant manager software. I deal with machine vision softwares. So basically, machine vision means machines plus computer vision. So whatever techniques we need to operate a machine in the terms of digital inspection, I work on it. So I'm leading a team of almost 10, and currently I am in Rajasthan for a customer visit where we install all the machines, and from the very scratch we are the manufacturers as well of the inspection machines, and then we develop the softwares as well. Okay, so I did my bachelor's and master's from Pune University in computer engineering itself, and I did my PhD in electrical engineering from Taiwan. The university was Southern Taiwan University of Science and Technology. My research mostly revolve around computer vision, deep learning, and machine learning. So, like in from past 3 years, I have been into automotive industry, where we combine computer vision techniques or AI techniques into machines. Yeah. So I would like to thank Dr. Yatin from Zeal University, from the Zeal College, who gave me this opportunity. We actually met in one of the conferences in South Korea, and from there we know each other. Thank you, Yatin, if you are listening. Okay, so I have almost 6 publications into international journals where my journals are into Q1 ranking journals as well. And I have I have attended 7 international conferences where I have also received best paper awards. So as of now, I have like 4 best research paper awards and for my researches. So the researches I will be showing later on in the end session, because first I would like to introduce, or I would like to come up with the techniques, what techniques are into automobile industry. So the agenda for the today's session will be like how the automotive systems have evolved into our automotive environment, normal basics of AI/ML, and then how these modern vehicles are architectured to use AIML. So the key applications which I will be focusing on will be ADAS system, which currently most of the vehicles are accompanied with these kind of techniques, ADAS system, powertrains and EVs, manufacturing and their quality, connected vehicles, and there some challenges and the future trends. So currently, what we can see is how the evolution have occurred in the traditional like automotive system have evolved from mechanical machines to software-driven intelligent system. The evolution is driven by electronics, softwares, connectivity, and AI. Today's vehicles are no longer just a transport system. Now they are like technology with transport. Um, Moving from left to right in the diagram, the traditional vehicles, they are dominated by mechanical and hydraulic systems, very limited electronics, and there were no ECUs or vehicle networking. All decisions were taken by human drivers and the limited safety and comfort feature. For example, like the cars which we have, like old cars like Maruti 800 Ambassadors and all, the power which comes from the engine was very raw. There were no safety features and all. So in the modern vehicles, we have introduction of ECUs, electronic control units, use of sensors and embedded softwares, multiple ECUs for different functions like engine, ABS, and airbags. And then we have the communication through vehicle networks like CAN, control systems, low speed, comfort features, flex
होटल में
race,
अंदर को
and
छुट्टी
Ethernet.
पड़ी थी नहीं कट 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 ये खट खड़ा आ रहा वो तो वही तो मेरे यहाँ गाड़ी में बस
Okay, I have muted the participant. Okay, so the key idea here is the vehicles have distributed electronic brains now. So in the next generation vehicles, what we have is shift to software defined vehicles like SDVs, vehicle functionality controlled mainly by the softwares, AI driven decisions making for ADAS and autonomy. Vehicles are now connected, autonomous, and electric. Basically, what we can say now is the cars are no more the machines now. They are the like computers on vehicles. Software defined behaviors, hardware acts like as a platform. Continuous feature upgrades and feature updates are also possible. So in the distributed architecture, what we see is each vehicle functions has a separate ECU, large number of ECUs across the vehicle, high varying complexity and weight, difficult software maintenance, and use of older and early modern vehicles. And then domain centralized architectures, what is that? The ECUs are the group of functional domains. Powertrains, we have different powertrains, like different power has been given, power riding modes, driving modes have been given, body is electronic, ADAS, reduced ECU count, better coordination between the functions, and improved performances and the scalability. And the third part is what the vehicles which we have currently in the market. It's like zonal architecture. Vehicles divided into different zone. One vehicle are divided into different zones like front part, middle part, the rear part, and the sides. ECU zone has zonal ECUs, one central high performance computing unit, high speed automotive Ethernet communication, which enables ADAS, autonomous driving, and AI processing. Why this evaluation is very important? Like it supports advanced safety features, reduces wiring and vehicle weight, enables AI, autonomy, and connectivity, feature ready architecture for smart vehicles. Automotive evolution today is not about engine alone. It is about softwares, AI, and system architecture. Okay, so why AIML is important in automotive? So automotive systems are becoming highly complex. Traditional rule-based control is no longer sufficient. AIML helps vehicle becoming more intelligent, adaptive, and predictive. Increasing system complexity, modern vehicles have hundreds of sensors, multiple issues, complex integrations. Real-time decision requirement where the vehicles must take decisions in milliseconds like sudden braking, pedestrian crossing, lane change, and high speed. ML models can process sensor data and respond faster than humans. So, and we also have like safety and efficiency demands. Like safety is the top priority in the automobile systems now. And then like what is uh, done using AI is collision avoidance, driver assistance, predictive maintenance. And it has also improved the overall fuel efficiency and battery management in EV systems. So the customer expectations as per the current market is like customer expects comfort, personalizations, and smart features as well. So AI enables, so on the top of it, AI enables adaptive cruise control, driver monitoring, personalized infotainment systems, and then vehicle behavior adapts to different preferences. And mostly we have like enable the autonomous decisions are making the systems more robust in such a way that they decide how what should be the force of the brake, adaptive speeds, and then change in the lane safety. So what is mainly difference between AI, ML, and deep learning? So basically AI, ML often they are interchangeably, but they are not always the same. So thus these slides explain like differentiation between or how it is related to using automobile examples. So if we are talking about AI, ML, or AI, so it is like AI is a broadest concept. It refers to machine that shows human-like intelligence, can involve logic and learning. So in the automobile domain, the vehicle understands the environment, plans the action, and with that actions make the decision of driving more easy. So the key concept here is for AI is intelligent vehicle behavior. And when we talk about ML, so ML is a subset of AI. So it is, everyone knows that the system learns from the data instead of explicit programming. So whatever the programs has been done, it is learning by itself. It is not like hard coded stuffs. And then performance, it improves its performance with the experience. And when we talk about deep learning is a subset of machine learning. So like AI, and then it comes to ML, and then the subset is deep learning. So it uses neural networks. Like everyone might be aware that deep learning uses neural networks with very different layers, multiple depth of it. Especially it is good at images, videos, and sensor data. So the camera-based detection, deep learning networks detects like lane marking, road edges, curves, and curves in the real time. So the relationship between AI, ML, and DL is like AI is the outer circle and ML is inside circle, and then DL is inside it. So AI does driving a car intelligently, and then ML learns from the past driving experiences. And then what deep learning does is seeing and understanding the road using the cameras. So why it is like deep learning is a critical in automotive. So in automotive system, what it handles is images, videos, radars, and lidar data. So when I was working with Mercedes-Benz, I will show you some examples like how we used radar and lidar data to give data to the car and how does it works. Deep learning also enables object detection, lane detection, and traffic sign recognition as well. So in automotive system, AI decides, ML learns, and deep learning sees. So it's like that. If a car is moving, it has all these three components. Okay, so what are the different types of machine learning? So we have seen that supervised learning, unsupervised learning. Supervised learning means like when we are giving some examples to learn. And unsupervised learning is like there are no examples, it is discovered by some patterns. And in the reinforcement learning, it is like uh, trial and then reward. We give some data and then it comes out of it. Automotive data source. In automotive data source, AIML systems in vehicle depends completely upon the data. This data comes from multiple sensors, which are fixed inside and outside the vehicles. Each sensor provide different types of information. So now if we have some cameras which are fixed on front, rear, and the surrounding, which provides 360-degree view of the car in from outside to inside. So it's like similar to a human vision. So it is basically used for lane detection, traffic sign recognition, and pedestrian or vehicle detection. So the front cameras will be helping us to detect the vehicles in front of us, collision avoidance, and then sign reading. Inside the cameras, what it does is it will be helping blind spot assistance, lane change assistance, and then driver behavior monitoring. The radar systems measure distance and relative speed. It works very good when in the different weather conditions as well, like rain, fog, or night conditions. So these kind of sensors are used for adaptive cruise control, cross traffic alert, reverse assistance, obstacle detection. And we also have lidar sensors. So these lidar sensors proves high precision 3D mapping, measure exact distance using laser pulses. And the applications what are based on lidar systems are like obstacle detection, speed and distance estimation, collision avoidance, emergency braking system. Nowadays lidar is very useful for autonomous driving. We also have ultrasonic sensors. So these ultrasonic sensors are very short range sensors, mainly used for low speed. Means these are used on low speeds. So basically, the applications provided by ultrasonic sensors are like park assist, parking system, close range obstacle detection. We also have IMUs, which are called inertial measurement unit, and GPS. So inertial measurement unit measures acceleration and rotation, helps in vehicle motion estimation, whereas GPS helps in providing vehicle position used for navigation and localization. Together, when we combine IMU and GPS, what we get is vehicle localization and path planning. And then we have vehicle CANs. So the CAN bus provides internal vehicle data, example speed, engine parameters, brake status, steering angle. So what are the important things here is like vehicle health monitoring, control system, and AI decision support. And we also have driver monitoring cameras, which focuses on driver state, monitoring the eye movement, head position, attention level. And once it recognizes that the eyes are getting closed or the head position are not straight to the road, then it will give some kind of warnings and all. Okay, now we have like AIML system architecture in vehicles, like how these AIML components are architectured in a vehicle. So we can see that AIML work inside a vehicle from sensing the environment to taking some action. It represents a closed loop control system. Each of the blocks plays a critical role in autonomous and ADAS functions. So the sensors which we already talked about were like cameras, LiDAR, radar, and GPS. And then we have data acquisition. The data acquisition is like the raw sensors will collect and will collect the data and synchronize it. Data from different sensors arrives at different rates. So the time stamping and buffering are also done at this stage. And then when we talk about the pre-processing, so the pre-processing is like raw data is very noisy and it is unstructured. So pre-processing includes like noise filtering, image resizing, sensor calibration, data normalization and all, which improves the quality before any AI processes or AI makes any decision. The persistent system in AIML, what is there? There is where AI and deep learning models are used. So the tasks which are performed by these perception systems are like lane detection, traffic sign recognition, traffic light, and object detection. So the major output of these section is like understanding of surrounding environment. The next point is localization. So the localization is like it determines where the vehicle is using GPS and map data. It is very essential for navigation and safety planning. And then we have the planning layer. So the planning layer converts the precision output into driving decisions, which includes like path and trajectory planning, obstacle avoidance, behavior planning. And then after behavioral planning, then what should the vehicle do next? So it comes under decision or control layer. So the control converts like this converts high level plans into controlled commands. Like it computes like steering angle, brake force, acceleration level, and then it ensures smooth and safe vehicle motion. Now, next we have accutators. So the accutator is a physical component that execute decision, which includes like brake, steering, and motor acceleration. This is where the software decision becomes a physical action. And then next we have feedback, or which is called the loop. Very important point, where the vehicle action changes the environment, sensors capture the new data, and the loop repeats continuously in the real time. So basically, in automotive, AI is a real-time closed loop system that the sensors thinks, decides, and acts continuously. Now, so what are the roles of these ECUs and then the domain control? ECUs, electronic control units, are the components like brains of the vehicle. As the vehicle functionalities increases, the role and the architecture of ECU is evolved. This in this particular picture, what is shown is like transition from traditional ECUs to next generation centralized controls. So in the traditional vehicles earlier, we used to have like 70, 100 ECU, 70 to 100 ECUs. Each ECU has function. It had a function specific. It means like it was programmed to have some specific to do some specific functions. Like examples like engine ECUs, ABS ECUs, airbag ECUs, and then window lightning ECUs. So the limitations what we had in the traditional systems were like it is exclusive. There were a lot of wirings in it, and the height and the high weight, because there are a lot of ECUs, so the weight increases and the cost also increases. So it was very difficult for the software updates as well, and the limited coordination between the ECUs. Now, the modern vehicle architecture, we have like ECUs are grouped into functional domains. Common domain ECUs include ADAS ECUs, which uses camera, LiDAR safety features. Powertrain ECUs like engine, transmission, and motor control. Body ECUs like lightning doors, and other components in the vehicle. So, what are the advantages on it? Is like reduced ECU. So since all these ECUs are grouped together to perform multiple tasks, so the number of ECUs are reduced, better coordination within the domains, and improved performance. And in the next generation architecture, we have like centralized shift of shift from domain ECUs to centralized computing, use of high performance SoCs, vehicle divided into zones like front, rear, left, and right. So the key components here are like zonal ECUs collect sensor and actuator data. Central computer runs AI, ADAS, and vehicle logic. High speed Ethernet switches we have. So in the diagram, we can see on the right hand side, it's like uh, these orange arrows, the arrows which we see here. So it defines it separates the car into different zones. It's like we have these orange arrows shows the sensors, actuators at the vehicle edges. So this zone ECU handles local input and outputs. The central computer which we have here, it performs AI processing, ADAS algorithms, and then vehicle control logic. So the switch, the switches here, the switches here enables high speed communication. And then, and what exactly is the role of high performance switches? So these high performance switches is required for AIML model workload, sensors fusion, and then autonomous driving, supports parallel processing, enables software defined vehicles. And then we have OTA updates. The software can be updated remotely. So the benefits of it is like features are upgraded once some software updates are there. We can fix the bugs in the vehicle very easily, and then the security patches can also be improved. So the reduced service center dependency. So it's like we don't need to go to the service centers for each and every stuff. So why this evaluation is important? It supports ADAS, autonomous driving, reduces wiring complexity, improves scalability, enable faster innovation cycle. So basically, the automotive industry is moving from many small ECUs to centralized software-defined computer platforms. Okay, so we have now ADAS feature, the first major AI adoption. So in the ADAS features, let's talk in details. Okay, so the first point here is our lane departure warning. So the lane departure warning alerts the driver when the driver unintentionally drifts out of its lane. So it does not control the vehicle, only warns the driver. It used mainly on highways or like well marked roads. So like we have the car which I'm driving is having lane assist system, where the vehicle will help me to keep the car between these lanes. You see these lanes, the car will be focusing on like how far or how close it is towards the left or the right. So it will give me the alert wherein it will show that which side the car is moving. And recently my car got updated where I see a new feature where it is like it will help me to keep in the lane. So the steering will automatically move and bring me between the lanes. So what is happening is like what kind of sensors are used. So like primarily we use there are some like front facing cameras. The camera continuously captures the road images. Here we don't need lidar for this lane departure warning. So how does AI plays the role in it? So it is like here we can see that the image what is so that the raw images captured by the camera, it is like it is it is capturing the road images. So here we see the lanes, and the green portion marked here is like in the green portion itself the vehicle should move. So how does AI works here is like it marks the lane for the decision. what it captures is road edges and the vehicle position estimation within the lane. So how does AIML works internally here? So it uses deep learning models which are trained on very like thousands of road images, where the model learns about straight lane, curved lane, broken and faded line marks. It works in real time. It's like the actions are in like milliseconds. So what are the warning mechanism? The warning mechanism, what we can see here is these are the warning mechanisms. Like lane departure is when the lane departure is detected, visual alerts on the dashboard, and then we have audio alerts like beep sounds, and then steering vehicle vibration or the torque. System activates, this kind of system activates only when the speed of the vehicle is above a threshold. So it's not like from the 0 to 20. So my vehicle works after 40 kilometers per hour. So and when the turn indicator, and also the lane departure will not work when the indicators are turned on. So why AI is needed here? So it is like a rule-based algorithm where curve roads, shadow, lightning conditions are monitored, and AI adapts to road variations, different weather changes, and lane quality as well. So it directly impacts our safety. It reduces accidents due to driver distraction, or if a driver is sleepy or something like that, especially useful for long highway drives. So the relation of higher ADAS level, where lane departure warning is a level 1 ADAS feature. Foundation, it is like lane keep assist and autonomous vehicle centering. It acts like building blocks for the it acts like building blocks for the vehicle. So the lane departure warning demonstrates how AI converts camera data into real-time safety actions. Okay, so now we have adaptive cruise control. This is one of the most successful real-world AI feature in ADAS, where it is like, unlike normal cruise control or adaptive cruise control, adapts speed automatically based on the traffic. So what is this adaptive cruise control? The adaptive cruise control is like it maintains a speed where we set the speed a safe following distance from the vehicle ahead. It uses sensors, of course, AI algorithms as well, and then it helps in reducing driver workload, especially on highways. So the sensors here are used in adaptive cruise control are radar, which is the very primary sensor. Cameras and radar fusion. We use cameras as well as radar fusion as well. And radar continuously measures distance to preceding vehicle and then relative speed. So like if I am setting a adaptive cruise control at 80 km per hour or 90 km per hour. So if the vehicle in front of us reduces the speed, then our vehicle also will reduce the speed according to the vehicle preceding it. So how does this adaptive cruise control works? So in the first case, we see no vehicle is there. Here, no vehicle is there, no preceding vehicle. So no vehicle is detected ahead. So what it will do, the vehicle will maintain the speed which is set like 100 kilometers per hour. And then here adaptive cruise control will behave very normally, like a normal cruise control. In the second case, what we see is there is a vehicle in front of our vehicle. So what will happen is the radar detects a slower vehicle ahead, and then adaptive cruise control will automatically decelerate, and the speed reduces to from 100 to 80 or so on. So AI estimates the safe distance and speed difference. In the third case, what we see is following at the what we see that like following at safety headways, like vehicle follows, just a moment. The vehicle follows the vehicle in front of it and maintains the constant time gap. It's like ahead, and then speed remains stable at 80 kilometers per hour, which is the speed of the preceding vehicle. And this is the core intelligence of any adaptive cruise control. And in the case 4, what happens is preceding vehicle changes the lane. The radar detects the road is now very clear. Now the adaptive cruise control accelerates back to the set speed. The speed gradually increases from 80 to 100 again. So it won't go beyond 100 because we have set the speed to 100 kilometer per hour. Okay, so next we have emergency braking. Just a moment. Okay, so this automatic emergency braking is one of the most critical safety application of AI in the vehicles now. Its goal is to prevent or reduce the severity of collision. Automatic emergency braking it can operate without driver input when it is required. So what exactly is automatic emergency braking? So it's automatically applies the brake when the collision is going to happen. So it works when the driver does not react in time or applies insufficient brake. So once I was driving my car and the signal was green and my speed was around 60 kilometer per hour, and the vehicle in front of me was also moving with a good speed. But suddenly, all of a sudden, that driver in the front car stopped the vehicle, and then I was unable to formulate in my mind that I have to apply the brakes. So until I was going to make a decision, my car was already my car was already stopped there. So it was because of automatic emergency braking. Like it sensed the speed of the preceding vehicle and then it applied the brake. So what kind of sensors are used here? So it uses radar, distance and relative speed, and it also uses camera, object and pedestrian detection. Sometimes sensor fusion also is it has very high precision. So here in this diagram, what we can see is the system continuously measures the distance between the object which is ahead of it. So it's like different distance zones are defined. So like D3, D2, D0, and D1 and D0. So D3 is the safer zone. Like this distance is the safer zone, and then when it moves to D2, it is like warning and then brake assist. And when it comes to D1, then the automatic brakes are applied, and if the automatic brakes are not applied, this 0 means it is a collision point. So AI predicts the time to collision. So the time from D3 to D0 is called as time to collision. So the multi-stage braking logic is applied here. Like we can see here in the stage 1. In the stage 1, warning and brake assist, object detected, some object is detected ahead, and the system will show some visual warning and audio warning, and then prepares brake system. So it will alert you as well as the AI system to prepare the braking now. So in the second stage, in the second stage, what is happening? If the driver does not react, the system applies moderate braking while speed is reduced. So in the third stage, in this stage, what is like strong automatic braking is applied. So the collision it can happen that the two cars can collide. The system applies maximum brake force and attempts to avoid collision or reduce the impact. So what is the role of AI in automatic emergency braking? So it implies object detection, vehicles and predictions, distance and speed estimation, collision prediction, decision making, when and how much to brake, like what kind of force has to be applied. So why AI is required here? For real world traffic is very unpredictable. So the rule based system cannot handle sudden movement or sudden cuts in, pedestrian crossing. So AI adapts to different driving scenarios. So how the safety is impacted here? It reduces rear to end collision, pedestrian accidents, and then one of the most life-saving ADAS feature. We have different ADAS levels. So this automatic braking system is a level 1 ADAS feature, mandatory in many countries, increasingly adopted in Indian vehicles as well. So hopefully the vehicle which I am driving is also having automatic emergency braking feature. So automatic emergency braking shows how AI can take control instantly to save lives when the human fails to react. Okay, so let me check. Okay, so Mr. Pritham has a comment here. Why object detection is needed for automatic braking system? So when we object detection is like I mentioned. Let me go back. Okay. So how will I know that I have to apply the brakes? So unless and until some object is detected in front of us, like for the first case, there is no vehicle, no object, or none of the objects are there on the road. So it has like no changes in the speed. So as soon as it detects some object is there, then only emergency braking will be applied. So if we don't have automatic braking system, if we don't have object detection, okay, I have muted him. Okay, so if we don't have object detection, then how will a vehicle know that when to brake and how to decelerate, and when to decelerate, when to accelerate it? So object detection is very important in this case. Okay, so the next point is blind spot detection. So it is one of the major limitations of human driving in the blind spot. So blind spot detection is a ADAS feature designed to assist driver during a lane lane changes and all. So it's significantly reduces the side collision accident. So what is a blind spot? So blind spot areas are not visible through the rear viewing mirrors or cameras or the side mirrors, what we call it. So if we have a side mirror here, this white portion is the angle where the mirror is looking into or the camera is looking into. So all these points, the blue points, the blue regions are the blind spot for the driver. So the vehicles or the two-wheelers in these green zone are hard to detect manually. So sensors are used in blind spot detection. So these short range LiDAR sensors are mounted at rear bumper corners, and then some system also use side cameras. Sensors continuously monitor the adjacent lanes as well. So how does it works? So the LiDAR scans the area. So suppose this area has the blue. blue regions are the blind spot. So here in the rear side of the car, we have the radar sensors. So what it does is it detects the vehicle approaching from behind and vehicles traveling parallel in the blind zone. So it also has, here you can see that on the mirror, we have a driver alert mechanism. When a vehicle is detected in the blind spot, visual warning icon or like on the side mirror, this kind of signal is shown that sensor is here and this vehicle is approaching very fast. And there is also a audio alert, like it beeps inside the car, and car is when the object from behind is coming very fast, then our steering also vibrates. Okay. So what is the role of AI in blind spot detection? So object detection in blind zones, trajectory predictions for nearby vehicles, risk management during the lane changes, and reduces false alarm by intelligent filtering. So why AI is required here? So in the traffic conditions are dynamic. So the multiple vehicles, two-wheelers, bicycles are there on the roads. So AI adapts to speed variations, dense traffic, Indian road scenarios. So there are very safety, a lot of safety benefits here, which helps in preventing lane change collisions, side when we move side, and then which is called side swipe accidents, and then it improves driver confidence and especially useful on highways. So it is like it is also a level 1 ADAS feature. When it combined with steering intervention, the blind spot comes into level 2 assistance, level 2 ADAS level. So blind spot detection extends the driver's vision using AI, making the lane change safer. So the distance calculation itself will work over here. Yes, the distance calculations is done in the real time. Okay. Now we have camera input. Okay. Okay, we have now lane detection. So the lane detection is a core perception function in ADAS. It is the foundation for lane departure warning and the lane keep assist. So it enables yeah, AI enables robust lane detection under real world conditions. So we have like camera inputs and then CNN based segmentation, lane curvature, and steering correction, which will help us to not to depart from any lane which could cause accidents. So the camera, a front-facing camera continuously capture road images. It acts as primary sensor for lane detection, provides real-time visual data similar to human vision. So the data collection and preparation is done. So here, we have those cameras, so that the cameras will be collecting the data, and then lane images are collected from real vehicles simulators like Unity 3D Sandbox. Okay. And then processing is the next step, which includes image resizing, color space conversion, and then brightness, adjusting some brightness which are required for the algorithm, and data augmentation, which will fill, zoom, or do different augmentations there. So the purpose of it is to improve model robustness, and it also handles different lightning and road conditions. After we have the data, now it comes the role of CNN based segmentation. So basically, this lane keep assist and lane departure warning works on segmentation of the image. So CNN performs like pixel level segmentation. It separates lane marking and then road surfaces background. So there is where deep learning is very essential for this point. So the lane curvature estimation. Once lanes are detected, the system will fit curves into the lane boundaries and estimates the lane curvature. It helps to understand the road bends and then vehicle alignment within the lane. So it will keep the vehicle within the lane. And then we have steering angle prediction. So the steering angle prediction is like CNN output, the CNN which we have. Its output is fed into the fully converted connected layer, and the prediction is made for like what should be the angle of any steering of the steering. So it converts the visual perception into control relevant kind of data. And then model training and evaluation. The model is trained using different parameters such as labeled lane images and corresponding steering angles. And then performance is validated using real world driving sensors, and then continuous evaluation ensures reliability. Steering correction. Predicted steering correction angle is now sent to the steering control, and then small corrective actions keep the vehicle centered in the lane and then stable the curves. So this helps lane keep assist. So this enables the lane keep assist. This is the feature which is called lane keep assist. And the outcome is very important here. The reduced lane departure accidents, which improves highway safety and driver comfort, and we have less dependency on the driver vigilance. ADAS lane detection shows how AI converts raw image camera images into steering decision in real time. Okay, now we have like computer vision in ADAS. How computer vision works in ADAS. So the computer vision enables vehicle to see and understand the environment. It is a core technology behind most ADAS features. Cameras acts as sensors, but not actually the sensor, but it acts as sensors while AI interprets the visual data. So the image classification, it answers that what is present in that image, and then the entire image is assigned some kind of a label. So it is like when we talk about automotive industry, it is like road type, what kind of road is it, weather condition detection, and traffic sense understanding. Object detection is like what kind of objects are present and where they are located. So the outcomes are like bounding boxes around those objects. The automotive examples is like pedestrian detection, vehicle detection, and these all points. Let me show you some example. Just a moment. Yeah. So this is one of my projects. We did this project for one of the our clients in USA. So they wanted to find out what objects are traversing in the specified area. So it is done by using YOLO V7, where objects are being detected. So these are the sample images which we captured from the phone and then we delivered it, and then actual images can't be shown here. It's like we can just show the R&D images only here. And then this is one of the interesting project where how many people or what objects are entering or exiting a space. So one of the project was like there is a shopping mall, and how many people are entering and exiting that place. So you can see that on the top of it, on the top we can see the ID numbers given to each object. The object is a person here. So we do here object tracking, where each object in the frame is given a new ID, and the tail behind it, it is showing like to which direction the tail is moving. It shows whether the person is exiting or entering entering the space. So here on the bottom there is an imaginary line. So if a person is approaching towards, then the tail will be moving towards, and if the person is moving away from the line, then it will be showing the tail is moving away from the line, or it is following the object. So how the tail is following the object, we define the number of people entering or exiting any space. So the computer vision allows us to see, understand, and react to the world just like a human machine or human driver, only only faster and more efficiently. Okay, now we have like some autonomous driving levels. SAE, Society of Autonomous Engineers, which defines 6 level of driving automations. So these levels describe how much control with the driver versus the vehicle. And then it ranges from level 0 to level 5, which is fully automatic. So in the level 0, there is no automation. So it is like no driving automation. Driver performs the steering, braking, and acceleration. The vehicle may give warnings only. Uh, Basic cars without, it has like basic cars without the ADAS. The driver monitors the environment. In level 1, the driver assistance, only driving functions is automated. Example, cruise control, late departure warning. Driver still controls the vehicle, and hands on the vehicle, eyes on the road. But in the level 2, it is like level 2 is partially automated, like 2 or more functions automated simultaneously. For example, adaptive cruise control and lane keep assist. Vehicle can change the direction of the steering and control the speed. The driver must continue here as well. The driver must continuously monitor the environment, be ready to take over anytime. Most of the car today are level 2. Most of the Tata cars, Kia, and Hyundai, these cars are equipped with level 2 ADAS features. In level 3, in level 3 conditions is like vehicle handles the vehicle itself handles the steering, braking, acceleration under some specific conditions. So the driver can take over required when the system request. For example, highway autopilot under some limited conditions. The system monitors the environment and the driver drives the car. And level 4, it is like high automation. Vehicle can perform all driving tasks only within defined conditions, like geo-fenced areas or like specific weather. No driver intervention will be needed inside those conditions. For example, like robo taxis in controlled cities, like we might have seen some kind of videos where the taxis are without the drivers. There are robo taxis. In level 5, it is like fully automation. Level 5, it is like fully automation, complete automation in all environments. No steering wheel or any kind of attention is needed. It is like truly driverless vehicle. And these kind of vehicles are yet to come, and scientists in Mercedes-Benz and Honda, they are already working on level 4 as of now. But in the market, as of now, we have only level 2 ADAS systems. And in India, it is very difficult to have level 3 as well, because our roads are not marked with lanes, and we don't have the edge of the roads as well. Not everywhere, but yes, mostly we don't have. So the autonomous driving is not like a binary concept. It is like a gradual transmission from driver assistance to fully anatomy of any vehicle. So what kind of stack we have for any kind of autonomous vehicle? So the autonomous vehicle rely on layers of AI stack. So like each layer performs a specific intelligent function. Together they convert raw sensors data into vehicle motion. So it's like in environment and sensor processing, the vehicle operates in a dynamic environment. Sensors capture raw data, cameras, lidar and radar, and GPS, IMUs. Sensor processing includes synchronization, filtering, and then calibration of these data which are captured from the environment, and then this prepares the data for the AI model. Then we have the perception layer. This perception layer answers what is around the vehicle, which uses computer vision and sensor fusion, detects vehicle, pedestrian lanes, traffic lights, traffic signals, and all. This is where deep learning is heavily used. Next level we have localization and mapping. So this localization answers like where am I, which uses GPS, IMU, and HD map. It determines where position with high accuracy, essential for safe navigation. Next part is motion prediction. Predicts the behavior of other vehicles, pedestrians, cyclists, or whatever objects are there on the road. It estimates future trajectories, enable proactive decision making. So this is a key AI challenge to find out the objects in a moving car, or when the car is moving, and then try to evaluate the environment and the moving object. We have next level is the path planning. This answers, or it gives us like what should I do next. So it computes safe path, speed profile, and then lane change decisions, and then avoid obstacles and collision. Next we have vehicle control. Can you tell me the best sensors, path planning, and continuous learning? Okay, we'll discuss it in the later phase. Okay, now we have vehicle control. It converts the planned path into control commands, and then control commands, which includes like steering, braking, and acceleration, ensures smooth and stable motion. We have like vehicle motion output as well. So the control command, which accumulates, or it gives us the steering system, which comes under steering system, brakes, and motor. Vehicle moves accordingly in the real world. And then the last part which we have here is the continuous learning, which is a very important point here, where data from the driving is logged, used for model improvement, edge case handling, and all, and enables software defined and evolving vehicle. Autonomous driving intelligence emerges from the coordinated operations of precision, prediction, planning, and then control. Okay, sensor fusion using AI. So no single sensor is very perfect for all driving conditions. So sensor fusion combines multiple sensor inputs to improve the reliability. So it plays a key role in intelligently fusing sensor data. So the sensors used in the fusions are camera, which provides rich visual information, good for object classification and lane detection. And we have radar, which accurate which accurately gives us the distance and the speed measurement as well, which works well in rain, fog, and in the night conditions as well. And we have LiDAR sensors. So these LiDAR sensors provide precision 3D depth information, accurate obstacle detection, and then the fusion combines the strength of all the sensors. So it means that, like, when we combine different sensors with different functionality, we come up with a fusion with strengths, with gives strengths to all the other sensors as well. So why this fusion is needed? So the individual sensor will have some kind of limitation. Like camera is affected by lightning. Like if there is different lighting conditions, the camera will act accordingly. And sometimes the radar has lower resolution, and then the LiDAR also is like expensive and very sensitive to weather as well. So the fusion compensate for individual weakness. So here in this car, we can see that sensors are placed all around the vehicle. So what does it do is, like, whatever cameras we have, these cameras are for vision. And then we have some LiDAR or radar sensors. So these radar sensors for distance and speed, LiDAR for 3D perception. So what we see, the 360-degree view of any vehicle here, it is based on the LiDAR. And then ultrasonic sensors for closed ranges, close range detection. Each sensors will cover a different field of view, and this fusion of these sensors, AI will combine all these inputs into a environmental role. So what is the role of AI ML in the sensor fusion? So ML model will learn, like, in what condition, what kind of actions were taken, sensor reliability, confidence level under the different conditions. And then AI weighs sensors into dynamically. So the inputs are changed to real-time actions, and it reduces faults detection and missed objects. So the types of sensor fusions, we have like early fusion, the raw data, it is combined. Mid-level fusion, it is like feature level fusion. Late fusion, decision level fusion. And then automotive system often use mid and late level fusion. So the benefits of this sensor fusion is, like, it improved detection accuracy, reduced false positive, robust performance in different weather conditions like rain, fog, low light, and then increased safety and reliability. So in this automotive applications, we have adaptive cruise control, automatic emergency braking, blind spot detection, autonomous driving system. So this sensor fusion allows vehicle to see the world more reliably than any single sensor could. Okay, now we have like in how these AI is used in EVs. So in electrical vehicles, the battery is the most critical and expensive component. Each battery management is essential for safety, range, and battery life. So the AI ML significantly improves the battery intelligence. So the battery state of charge, SOCs, the battery state of charge prediction. So it indicates how much charging is remaining in the battery. The traditional methods are inaccurate, and it's under real driving conditions. So ML models, what it does is it uses voltage, current, temperature, and driving patterns, and provides more accurate range estimation. So the range estimation which we see in EVs are the outcomes of, or the results of, ML model. So, and then the state of health estimation. The health estimation indicates the battery aging and its degradation. So AI estimates like capacity fade, internal resistance increase, and which helps in predicting remaining useful life. So it is very important for warranty and safety compliances. We have next point is range prediction. So in range prediction, AI predicts the driving range based on driving, what kind of driving style we are having, road conditions, temperature, and then the traffic. It is very dynamic and personalized range estimation. It reduces range anxieties. Thermal management. Thermal management must be kept, this battery temperature must be kept within some kind of a safety limits. So this AI controls the cooling of the fan, the heaters, and then it prevents overheating and thermal runaways. So in the diagram, it is shown that this battery cells provides voltage, current, and temperature data, and the cell voltage. It measures like what unit collects real-time data. AI-based algorithm computes all state of charge, state of health, state of energy, thermal, and then the fault diagnosis as well. It also controls signals sent via CAN, and then control cooling, heating, and then displaying it on the display which we have inside the car. The fault diagnosis, and this is basically for the safety purpose. So the AI detects like cell imbalance, over voltage, and then the over current. Like if there are voltage, more voltage is coming from the battery or more current is coming from the battery, it enables early fault detection and then improves vehicle safety. So the what key benefits we have here is like ML will improve battery life and safety, optimized charging, and of course discharging, reduce degradation, and increase reliability. So in EVs, AI transforms the battery from a passive energy source into an intelligent self-managing system. Predictive maintenance. So the traditional maintenance is like either it is reactive or preventive. So it is reactive means after failure, or preventive means it is like a fixed schedule. So the preventive measurement, the maintenance uses AI to predict failure before they occur. So in basically what we do in the current market is like it is we take some action either after some failure occurs, or when we will check when it is, or we will check when there is a warning or something like that. Okay, so it is widely used in model vehicles, EVs, and manufacturing, and different manufacturing industries as well. So the data source for predictive maintenance is like vibration analysis, where we see sensors monitoring vibrations of patterns, motors, bearings, and gearboxes. Abnormal vibration indicates early faults. Then we have temperature trend, continuously monitoring of temperature. Sudden rise indicates like overheating, lubrication issue, or electrical faults. In the historical fault data, we have like past failure records are used to train the ML model, identify the failure pattern, and it enables learning from previous breakdown. So the basic role of AI ML here is AI model analyzes sensor trend or sensor data, anomalies, and then deviation from normal behavior. AI predicts probability of failure and then remaining useful life, and then life of the component. moves from reaction to prediction. So before something is going to break down, we will have the warning beforehand. That in the diagram which we can see is like the physical space. This is a physical space, which means like the real-time car. The real vehicle with sensors, actuators, and edge computing generates continuous operational data. So in the virtual space, what we'll do is like digital replica of the vehicle or the system, which uses AI model, data analytics, simulation, predictive failure virtually before the real damage occurs. In the cloud-based interconnections, what we do is data flows between physical vehicle to digital twin, and then feedback improves accuracy continuously. Then feedback and continuous improvement. In the feedback and continuous improvement, what we have is that AI model will give accuracy to improve over the time. And as the new data comes, it is very good, or it is better for the predictions, and then system becomes self-learning. As soon as the new data comes, the system will learn by itself. So the benefit of this predictive maintenance is like reduced breakdown, failures detected early, avoid sudden vehicle stoppage, lower maintenance cost, replace parts only when it is needed, or avoid necessary servicing. And then increased uptime. Vehicle availability increases, which will help us for ideal for fleet and commercial vehicles. The automotive examples are like EV motor health monitoring, battery fault predictions, fleet vehicle maintenance scheduling, manufacturing equipment in automotive plants. So predictive maintenance transforms maintenance from a cost center to intelligent data-driven strategies. Okay. So next we have, now let's move to like how AI is in use in automotive manufacturing. So we have AI is not very limited to vehicles. It plans for other applications as well. It plays a major role in automotive manufacturing. Modern factories are smart factories driven by data automation. AI improves quality, efficiency, and its consistency as well. So the vision-based inspection is like camera inspection component on the production line. AI replaces manual inspection. It detects surface defects, scratches, color variations, and then it is basically for faster and more human accurate than these are more accurate than human. So the defect detection, it includes AI model are trained on normal parts, defective parts. It can identify paint defects, welding defects, assembly errors, reduces false rejections and missed defects. We have robotic automations as well, like AI powered robots performance, where we do welding, plant painting and all, material handling. Robots can adapt to various variations in the parts as well. It improves precision and reliability. So let me show you some examples. Like this is the current system which we are working on. Like this is a plastic roll of a plastic sheet or any kind of sheet, whether it is a plastic sheet, paper sheet, or a metal sheet. Like we worked for Reliance, where they manufacture solar panels. We worked for different companies which manufactures the Tetra packs which we have, like fruities and another ORS drinks which we have. So once they are manufactured, we check whether it is having some fault or not, or there is some hole in it or not. Like the medicines which the medicines in which the packaging of the medicines. So how these medicines are being packed, the packaging, aluminum packaging also we do manufacturing. So what is this like? We have a sheet here which is moving at the speed of it varies from like 70 meter per hour to 600 meter per hour, and then we have a frame here which is equipped with cameras. So these cameras are basically line scan cameras or area scan camera. So for the fast moving objects, which works on more than 80 meter per minute, so there we use line scan, grayscale line scan cameras. And once the sheet is moving, this camera will capture each line of it. So the cameras have the resolution of 4K and 8K as well, 16K as well. So as of now, we are using 8K and 4K cameras depending upon the application. So as soon as the defect is captured in the camera, we are using two different softwares. One software is to get those raw images, process it, and then find out the defects. And then the second software which is used here, which we can see on the screen, it is like it will show us what kind of defects were captured, at which location was it, and then what meter was it, what was the confidence of it, what was the height and width of the system. So let me show you today's video, what we did today. So here is the roll, and you see this frame, silver frame. There are two different cameras, and two cameras are below this frame. So this film is being inspected from top and bottom. So this sheet is moving, and it moves along here, and it comes below the camera. And you see, so this camera is looking here, and then we see the defect, something like this. So this is the screen. I have intentionally kept it small because we cannot show data this way. So whatever we can see here is like the defects are on the sheet, like it is somewhere the threads are missing, some contamination is there, or some other types of defects are there. This is the XY map, like it moves from 0 to the length of the sheet, and it will show like where exactly in the sheet was the defect. And here are the parameters what we set for the defect detection. Okay, so on the top of it, AI transforms automotive manufacturing from manual inspections to intelligent data-driven prediction. So usually what happens is before we installed this camera system, I'll show you something. Okay, so a person will sit here and will monitor this side of the sheet. So once the defect comes, he will come here. He will come here, and from here he will stop the machine, and then he will go and repair the sheet. So there is a human required to monitor the sheet and then stop and then do the required stuff. So we are doing it using automotive our defect detection system. So this video I captured it today itself when I was there in the factory. We came here to Rajasthan to I basically belong to Pune. Our office is in Pune, and this our inspection system, and we manufacture this system, and then our softwares and all. We do all kind of electrical component wiring and all, and then we supply our panels with it. And I came here to Rajasthan for installing this machines and get the software running. Okay, so okay, now connected vehicles and AI. In the modern vehicles are no longer associated like isolated systems. They are connected to other vehicle infrastructure or the cloud. So AI uses connectivity to make better predictive decisions. Sorry. So V2V, vehicle to vehicle communication, vehicle to vehicle exchange data with nearby vehicle shared information. It includes speed, position, and sudden braking events. AI uses vehicle to vehicle data to predict collision, and then warn drivers in advance and improve road safety. And then we have vehicle to infrastructure communication. So vehicle can communicate with traffic signal, roadside units, and then traffic signs, signals, and the information which are shared are like signal timing, road conditions, speed limits, and enable smarter driving decisions. And we have cloud-based analytics. Vehicles upload data to cloud AI process. The cloud AI processes large-scale traffic data, driving patterns, and then vehicle health information as well. So these models are updated and sent back to the vehicle. And then we have real-time traffic prediction. These AI systems will predict the traffic congestions and then accident-prone zones, enables dynamic route planning, reduced travel time, low fuel or energy consumptions. So why AI is essential in the connected vehicle is like massive data volume from vehicle infrastructure and the cloud. AI filters, analyzes, and then extracts the insights, which manual processing is where the manual processing is quite impossible. In the automotive vehicle, collision avoidance, warning, then smart navigation, predictive maintenance, and fleet management are few applications where AI is needed. So the connected vehicle combined with AI transforms driving from reactive to predictive mobility. Next, we have cybersecurity and AI. The modern vehicles are software defined and connected. So the connectivity introduces cybersecurity risk. So AI essentials to protect the vehicle from known and unknown attacks. So intrusion detection system identifies unauthorized access. The AI here will monitor ECU behavior, network messages, software activities, and then detect abnormal behavior in the real time. So anomaly detection in CAN traffic. CAN buses carries critical vehicle control messages like AI learns normal CAN traffic pattern. It can detect message flooding, spoofed messages, and then timing anomalies. It is effective even for 0-day attacks. So secure OTA updates. OTA updates improves vehicle feature and security. AI ensures authenticity of updates, integrity of softwares, and then safe deployment without system compromise. And then why we need AI in automotive security is like rule-based system detects only known attacks, but AI learns normal behavior and these flag deviations, enable detection for previously known attacks, and then uh, AI helps to detect some kind of unknown attacks as well. So in the diagram mentioned here, it's like AI will detect the onboard. It will detect the onboard system defect, suspicious activities, something like that, and then security events are logged. And in the second stage, we have reports which will the vehicle reports to events or to backend SOCs. It analyzes the data from single vehicle and then the entire fleet, and then we develop contour measures. Contour measures are like developed, designed, and tested. Then we deploy security patches via OTA updates, and then these attacks, automotive attacks, are the examples of these automotive attacks are like ECU spoofing, CAN injection attacks, and then unauthorized OTA updates. And then we also saw the vehicles are misbehaving because of sensor manipulation as well. So the benefits of AI-based cybersecurity is early threat detection, the fleet-wide production, and then reduced attack impact, and then continuous security improvement. And um, as vehicles becomes more smarter and more connected, AI becomes strongest defense against the cyber threats. Now, what challenges which we have in the automotive AI? So basically, although the AI enables advanced automotive features, deploying AI in real vehicle is very challenging. Automotive AI must work under strict safety, like timing and then hardware constraints. Here we will see like what challenges we are faced by us in the industry. So the real-time constraint is like automotive systems are hard real-time systems. The decisions must be taken or made in milliseconds. For example, emergency braking and then collision avoidance. AI model must be fast. Uh, it must be deterministic and reliable as well. So the a delay in decision can cause any kind of accidents. Like there is delay in automatic braking system, then the car will collide to the object in front of it. Then we have safety certifications. So like automotive systems must comply with functional safety standards. So there are different if someone wants to learn about functional safety, there are different courses also available to learn about like what ISO 26262 requires, like predictable behavior, intensive testing and validation. The AI models are data driven and probabilistic. Like certifying AI based decision is very complex. Safety approval is a major bottleneck here. So we have data labeling. AI models require large amount of label data, and then automotive data includes images, videos, and sensor data. Manual labeling is time consuming and it is very expensive as well. Specifically difficult for rare scenarios and edge cases. Data presentation cost is often higher than a model development. And then okay, then we have edge computing limitation. AI runs on vehicle ECUs, not cloud servers. So the constraints which includes here is limited processing power, limited memory power, and thermal limits. So the AI, the large AI models must be optimized, compressed, and efficient, so that it gives balance, performance, and hardware cost is less. So the summary, when we summarize these challenges, is like real-time constraint is like speed is very critical. Like the action should be taken in milliseconds. Safety certifications, AI must be probably very safe, and data labeling cost should be minimal. And then explainability, need for trust and transparency, and edge limit is like limited onboard resources. The biggest challenge in automotive AI is not intelligence alone. It is like, but making AI safe, real time explainable, and deploying the in the real vehicles. Okay, so ethical and safety concerns. As vehicle become more autonomous, ethical and safety questions become critical. AI system does not just assist, or they make life critical. They make life critical decisions as well. Hence, what we say is ethical design is important as the technical performance. So the decision making in the critical scenarios is like AI may face no-win situation. For example, sudden pedestrian crossing. If a pedestrian is suddenly crossing the road, it is very difficult for a automotive vehicle to make a decision. And then If the multiple objects are there, then also it fails. What kind of question arise here is like, who should the vehicle whom should the vehicle prioritize? It's like, what object should be prioritized first, and then how much risk is minimized in such kind of scenarios. So the ethical decision logic must be predefined, and it's must be validated. Bias in training data, AI system learns from the historical data. So if the training data is biased, it is like there are a lot of variations in the training data, then certain road users may be is like it may be underrepresented. Like performance may degrade in specific regions or conditions. For example, poor detection of pedestrian in night conditions, non-western traffic patterns, which requires diverse and inclusive data set. Responsibility in accidents. In case of AI controlled vehicle accident, who is responsible? Driver, manufacturer, or a software developer? There is a major legal and ethical challenge here. So clear accountability framework are required here. Regulatory compliances, government requires safety validations, transparency, auditability. AI must comply, the AI systems must comply with automotive safety standards, data protection laws, and regulations different across the countries. The compliances is mandatory for real world deployment as well. So why these ethics matter in automotive AI? Vehicle interacts directly with human life. Ethical failure can lead to loss of trust, legal consequences, public backlash. I mean, ethical responsibilities of AI adoption. So basically, the technical excellence alone is not enough. Automotive AI must be safer, fair, transparent, and accountable. So in automotive AI, the most important question is not what the system can do, but the question is like what it should do. Okay, so the future trends here in automotive AI is still evolving very rapidly, and every day by day we see a lot of researchers coming out. So in the future, the vehicle will be software driven, continuously learning, and then intelligent by design itself. So so software defined vehicles means like the vehicles uh, where the software defined functionality will be used for the features like features can be different kind of features can be added, improved, or updated with OTA. Hardware becomes a platform and software becomes the differentiator, similar to smartphones on wheels, something like that. So the AI chip for automotive is like general purpose issues are not sufficient for any kind of AI workload. So specialized automotive AI chips are emerging, which are designed for low latency, high reliability, low power consumptions. So which enables real-time AI safety inside the vehicle. Self-learning vehicles learn from driver behavior, road conditions, fleet level data, and then performance, which improves over the time, which leads to better safety, personalized driving experience. So this vehicle intelligence and intelligence evolve very continuously, very rapidly. Digital twin in a virtual replica of a vehicle, which is used for testing, simulation, and predictive maintenance. Uh, Changes are validated virtually before the real-time development, which reduces the cost and the risk. Generative AI in design and testing. Generative AI helps to create a new design, simulate edge cases, generate test scenarios, accelerate it accelerates the vehicle development and validation cycle. So the faster innovation with reduced development time. Okay. So the overall impact of these trends has like faster innovation, safer vehicle, better customer experience, shift from hardware centric to software centric automotive industry, and then the future mobility is not just the electric or the autonomous. It is an intelligent software defined, and it is continuously learning. In the research opportunities, the automotive industry is rapidly shifting towards software, AI, and electronics. Engineers today must be multidisciplinary. Sorry, should be talking about skills for the engineers here. So the AI engineers today must be multidisciplinary, and like embedded system, AI automotive runs on embedded hardwares, not laptops. Engineers must understand like what are microcontrollers, real-time operating systems, ECU architecture. Python and ML basics are needed. Like Python is widely used for data analytics, AI, ML model development, prototyping algorithms, etc. ML basic includes classification, regression, neural networks. Even embedded engineering engineers need AI awareness nowadays. So automotive protocol vehicle rely on communication networks such as CAN, LIN, and FlexRay, automotive Ethernet. And then engineers must understand like what kind of message structure, timing, fault handling are essential for integration and diagnosis. Functional safety automotive systems must be safe by design. Knowledge of like ISO 26262 safety life cycle, and then ASIL levels. Safety thinking is critical when working with AI. Safety is non-negotiable in any automotive. System thinking is like uh, automotive systems are complex interconnected system. Engineers must see how sensors, softwares, and hardwares interact to each other. End-to-end system behaviors, which helps in debugging, architecture design, and trade-off decisions. Advice for the faculty members, it is like we need to align curriculum with industry needs, which combine theory plus hands-on labs, AI plus embedded systems, safety plus real-time use cases, which encourages we can encourage students to do industry projects and interdisciplinary learning. And so the future of automotive engineer is not just a mechanical or electrical expert, but a system-oriented, AI-aware problem solver. What the kind of research opportunities we have is like automotive AI is a fast evolving research domain. So many real world problems are still unsolved. This creates strong research opportunities for faculties, research scholars, and industry academic collaborations as well. This lightweight AI models, automotive AI runs on resource constrained ECUs. So the large deep learning models are often impractical. The research focuses on model compromisation, quantization, puring, and then the end goal should be high accuracy with low compute and memory. Explainable AI is like automotive AI driven are safety critical. So the regulators and engineers must understand why decision was made, and then research areas are like model interpretability, decision transparency, and trustworthy AI, and critical of certifications and ethics. Edge AI, most automotive AI runs on the vehicle edge, not the cloud, challenging which includes like limited compute, power constraints, real-time execution. So the research topics which can come out of it is like efficient interference, hardware AI, hardware awareness, and then with AI, and then edge computing. Safety and validations like traditional validation methods are not sufficient for AI. So the researchers must focus on testing AI under rare and corner cases, formal verification of AI system, and then scenario-based validations. And then energy efficient ML AI models consume electrical power, battery energy. So the research areas are like energy aware training, low power inferences, AI hardware, and this kind of things. So why these topics matters is like high industry relevance, strong scope for publications, patents, and sponsored researches, which aligned with smart mobility, sustainable transport, and then national global research priorities as well. The suggested audience specific angle is like for faculties, interdisciplinary research like AI, automotive, and safety. For students like MTech and PhD topics, industry relevant problem statements. So automotive research is not just about smarter vehicle; it is about making intelligence safe, efficient, explainable, and deployable. Okay, so I think I'm running out of time. So thank you so much. And then if you have any questions, please we can go through it.
In participant, you can ask the questions. Yes, participants, you can unmute and ask the question.
Hello, sir. There is one question. Hello, am I audible?
Yes, you are audible, sir.
Yeah, I just have one question that in the presentation, sir has shown that the fault detection on the conveyor belt. So I just want to ask one question, whether it is a proprietary software it is being used, or can we use any open source software available from the GitHub?
Dr. Harshad?
Someone muted me. I'm sorry. Am I audible now?
Yes, sir.
Yes.
You are audible.
Yes. So your question is like what kind of softwares can be used for it, or sorry, can you please clarify the question?
Yeah, you shown that conveyor belt over where the fault detection can be done with the help of software, which you mentioned that you have implemented it somewhere. So I just want to know whether it was from the proprietary software or there are available software which we can use.
See, there are a lot of softwares already, open source softwares available in the market. But the thing is, like the software which we are using or which we have developed, we developed it from the very scratch. And it is like for every customer, we customize the software. Like I mentioned, it's like we have different kind of sheets, plastic sheets, paper sheets, metal sheets, and also depending upon that the core algorithm for defect detection changes, so we have to work accordingly. So sometimes we use anomaly detection, sometimes we use conventional computer vision algorithms or digital image processing algorithms, so depending upon that we use. So as of now our software is the software which we use are developed in-house.
Okay, thank you.
Some more questions. Someone was asking about sensors for path planning and continuous learning, right? So there are some sensors called monocular, vision sensors, which can be used, monocular sensors, cameras, stereo cameras, and LiDAR sensors are used, and then radar is also used in, and many other ultrasonic sensors are also used in uh, monitoring. What else? You presented. What about the usage of predictive maintenance toolbox available in MATLAB software? I'm extremely sorry, I'm not aware about MATLAB because I have never used MATLAB for any kind of programming and all. Is it using any specific software? So Mr. Pritham has asked.
Yeah, that was the same question you just answered.
Okay. So distance calculation itself will work over here. So in any object detection algorithm, the decision has to be made on the real time in milliseconds. So basically, it's like, if whenever we try to take any actions on the basis of object, so here the object detection is the key of any actions to be taken for lane detection or adaptive cruise control and all. I have lot many things to discuss as well, but the thing is, like, we are already running out of time, and mostly it is a dinner time for everyone, so I won't take much time. If some more questions are there, you are welcome with the would like to connect with you personally on LinkedIn. Kindly share. You can search my name, it will be there, and my name will be there will be in Chinese letter as well, so you can search for me, Mr. Dinesh. I'll send you the connect.
Okay, any other participant question? Okay, Dr. Harshad.
Hello, sir. Am I audible, sir?
Yes, sir.
Yes,
Sir,
yes, 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 sir.
sir,
Yes, sir. Please go ahead.
this is Dr. Arun again, sir, from CVM University.
Mhm.
Sir, how the environmental. Yes, sir. Sir, so the vehicle is going to subject in different environmental conditions. So how you have included the signal, I mean the noise ratio into your sensing signal, sir? Actually, I want to know about it. It's a plain
Uh,
question. Yes, sir. How you have considered this boundary condition for your problems?
so boundary conditions like noises in the sensor data, right?
Yes, sir. Yes, sir.
So basically, these noises in the sensor data are kind of the data which are simple, in the very simple terms, which are outliers, correct? So
Yes, sir.
these outliers are maintained, or these outliers are monitored through the AI algorithm, where regression works, and we try to bring it to the cluster, or maybe we try to avoid from the cluster. So basically, we work on regression algorithm to deal with this kind of outliers.
Okay.
Yeah. So basically, we suppose a sensor is captured some data. So
Yes, sir.
we can monitor it through like, what is the variation between the previous data and the next data. So
Okay.
suppose first data is something like point number 2, like the intensity is 2, and then
Yes.
the point number 2 is the intensity is 10, and the point number 3 is intensity is 2, so, or
Okay.
3, so it is like 2, 10, 3. So what we see is the previous and the next data, and on the basis of that we try to find out, like, 10 looks something different. So by using by using ML algorithm, we try to bring it closer, or we try to avoid it.
Okay.
Because
Okay.
sensors cannot, so sensor data cannot be, we cannot, what we say that we cannot fine tune the data coming from the sensors. We can just accept or reject the data.
Okay. Okay, sir.
Yeah.
Fine. Sir, actually, it was a wonderful presentation, sir. I think you have completely involved in the presentation. So, thank you so
Thank
much.
you, sir.
Thank you so much for the presentation, sir.
Thank you so much
Because
for the appreciation. Thank you so much, sir.
no one will
Sir,
carry for more than 1.5 hours, but you have taken the session beautifully. Thank you so much, sir.
Thank you so much
hello,
for the appreciation. Thank you
hello,
so much,
sir.
sir.
Nice. Okay, sir.
Hello, sir.
Yes, yes, yes,
Dr.
yes, please.
Harsha,
There is another query. Can you hear me?
Yeah, yeah, yes, yes, yes. I can hear you. Please
Yeah,
go ahead.
actually, you have mentioned about the LiDAR sensor.
Hmm.
So, LiDAR sensor we are trying on the basis of ROS, that is robot operating system.
Hmm.
But it is not giving that much accuracy which we require. So,
Hmm.
any other sensor which is more competent and latest one, which is in market, can you suggest for integrating with AI and integrating with actually ASRS system?
See, actually, I am mostly into AIML. Okay. So,
Okay.
what kind of we have a different team who are working on capturing. So, okay, I will tell you the entire story if you have time. So,
Yeah.
when I was working with Mercedes-Benz, I'll tell you that story. So, we have collaboration with NVIDIA. And
Okay.
NVIDIA, like when we had a collaboration, so for capturing the data for LiDAR, radar, and GPS data, we provided our Mercedes vehicles to NVIDIA, and in exchange, NVIDIA was providing these sensors to us. So we work in the collaboration, like we from point A to point B. Uh,
Okay.
Let me share my screen very fast,
Yeah.
and
Yeah.
so that I can explain you a little bit visually. Talking it verbally won't make any sense.
Yeah.
Sorry. Yeah, is it visible now?
It's blank, but
Yeah,
yes,
it
it
is
is
visible.
visible.
It is
Yeah, it's
visible, right?
visible.
Okay,
Yeah.
so let's start from here. Uh, so once from this point, can you see my cursor as well?
Yeah. Yeah. Yeah.
Okay, so from this point to this point, if we are traversing, so you can see different color lines. So this green line is the center line. These blue lines are the lane, what do you say, that lane dividers. Okay,
Okay.
so what is happening here? And these are the another lines, like maybe this is a bridge, and maybe there are some what do you say, boundaries.
Mm.
Yeah. So what happens is, when we car travels from this point to this point, we will capture these are the points which we get from the lidar and the lidar sensor, and then we try to plot it on the map. So on the basis of this, what we do is, for me this is a outlier. Okay, this data is a outlier. For me, this blue and green lines are accepted. So what we do is, like I mentioned, by using ML algorithms, we try to discard these lines. And
Okay.
like here also, you see these kind of data we try to plot. Like Google is using their Google Maps, right? Google has Google Maps. So Mercedes have also developed their own high definition map. So I was the part of the team when I was working for this.
Okay.
Something like
Okay.
this we'll try to make. This is the imaginary image created using the camera and the lidar sensors. So I'm not sure what kind of sensor were it. I'm really very sorry, but I know how
It's
to
okay.
deal
But
with the
there
data.
is one more question after this discussion. Generally, you might have worked about the distances, right? So
Hmm.
for outliers, mostly we are preparing at the initial level box plot. But is there any standard method you have used for this distance, or any algorithm you have developed for detecting the outlier?
So see here, for detecting the distance between from my car to the car ahead me,
Hmm.
ML algorithm is not needed. Actually, what we need is the physical distance between the two cars. So if a physical
Okay.
distance between the two car is below the threshold, it will show the warning, and if it is not, if it is above the threshold, then it works okay. So
Okay,
ML
means
algorithm is not.
you might have worked with a threshold based function you might have created and accordingly you have used.
Yes. This is a threshold based
Got it.
function. Yeah. There is no ML required here.
Yeah. It's basic function you might have tried
exactly,
and
is the basic
threshold
function.
and based on
Not
the
everywhere,
distances.
AI will work, right?
Yeah. Basic functions need to
Yeah,
be
basic function should
sorted.
be inculcated as well.
Yeah.
Yeah.
Thank you so much, sir, for my query.
Thank you.
Yeah.
Any other questions, please?
Okay, sir. There are no more questions from the participant right now. Myself, Professor Shivaji Shelar. Thanks, Dr. Harshad, for presenting presentation on AIML in next gen autogen this thing. Dr. Harshad, I take an opportunity to thank on behalf of Zeal College of Engineering and Research for your wonderful presentation here. That the way you have demonstrated the various systems of automotive, we feel it is rich, and you also put in concern that there is a safety associated in AI programming also. So in future, that all that safety will be taken care. So thank you for your presentation and being with us.
Thank you so much, sir. Thank you so much to the Zeal Education for providing me the opportunity. I really feel privileged to have communication with researchers, and I will be very happy if we can the professors, since I am from the organization like a company. So if any organizations, institutes, or colleges wishes to have individual collaboration are also welcome. So like company level collaboration is very difficult, so because there are a lot of constraints has to be taken care. So if anyone wishes to have individual level collaborations as well, I am open to it, and will be, because since I am working with some universities, some colleges in Pune for their collab researchers and the collaborations. If anyone is interested, please let me know. I will be more than happy to help and collaborate. So I'm pasting my link here. You can connect my LinkedIn profile. You can connect with me anytime you want, and I'm adding my phone number as well.
Arshad, already I have sent a connection request to you.
Yes,
This
sir.
is
I have
Anil
received.
Kumar.
Yes,
Yeah.
yes, sir. I have received. I have received the name of just a moment. Mr. Pritham, right?
No, it's Anil Kumar. Tuluri
Oh,
Clinic.
okay. T Chiranjeevi Anil Kumar.
Anil
Okay.
Kumar. Yes.
Okay, sir. Okay,
I
sir.
will connect with you because I want to plan some activities.
Sure. Please let me know. I
Yeah.
have accepted the invite.
Okay. Thank you.
Thank you so much, sir. Thank you so much.
Okay, thank you, sir, for your forward invitations to connect with the institutes. So I will discuss with our management whether we can have some collaboration here.
Sure.
I think no more participant has asking question, so we can end the session here, sir.
Yeah. Thank you so much, everyone. Thank you so much, Zeal. Thank you so much, sir. Really grateful having communication with all. Yeah, thank you so much.
Thank you, sir.
Thank you, sir.
There is a small announcement for a participant. Tomorrow will be the last day of our FDP. On tomorrow, there will be 3 technical sessions followed by online assessment. Kindly note that the first session will commence at 2 p.m. and the test will be conducted from 7 p.m. to 8 p.m. So Please remember, tomorrow we are going to start at 2 p.m. Thank you. Good night all.
Sir, exam has to be written in the website or